Hello, students. I'm Pallavi Sonal, your maths instructor for today. So, what are we going to study today? This is the ninth class book, NCERT Ganita Manjari, and this is the chapter 5. What is the name of this chapter? I'm up and down and round and round. Very, a different kind of name for a chapter. So, can you guess what this is about? What this chapter must be all about? This is all about circles. So let's start with some, common circles that we see around us. Can you think of some, shapes in the nature that resemble like circles? Okay, I'll give you some examples. So let's see this one. What is this? So this is something which you see when you step out in the night on a full moon day. This is our full moon looking so bright and beautiful. It looks like a circle, right? Now, this is another form of circle. If you see a drop of water falling in a lake or in a pond, or even when it is raining, you put a bucket of water outside and you see the raindrop falling in the bucket. What it produces? It produces all these circles. Okay, and we'll study later, what such circles are called. Then see another example. If you are a very clever chef and you are able to slice nicely the oranges, what shape does it look like? Circle. Another thing I'll show you. What is this? This is a sellotape. So this must be lying commonly, this is a commonly found thing in every house. What is the shape? Circle. So enough of all the circles. Now, tell me what is the one property which is common to all the circles. Every circle has that. You would have studied that in your lower grades as well. Yes, that is the center of the circle. Okay, so this is the center. Now, what is exactly the center of a circle? So, center of a circle is a point from which any other point on the circle is at the same distance. For example, this is our point A. Okay, this is our point A. Maybe I'll make it with this point A. This is our point B. This is our point C. I'll call this, I'll name this as B. I'll name this as C. And this is my point O. Now, what I'm trying to say is this distance is OA. This distance, this is OB. This distance, it is OC. So all these three distances, OA, OB, OC, all are equal. And only when all are equal, we can say that this O is the center of the circle. So what is a center of the circle? The center of the circle is the point from which every point on the circle is at a equal distance. So what we learned about center of the circle. And what we learned about the center of the circle is all points on circle are equidistant from the center. Cool? Okay. And from this only we can give a definition to the circle. So what is the definition of a circle? Circle will be the set of all points on the plane that is that are equidistant from the center, or equidistant from the center, or which is a given point on the plane. Okay, so when I'm defining circle, I'm saying it is the set of all points on the plane. Example, A, B, C, these are all points on this plane. A plane is a two-dimensional surface. For example, the screen of the laptop, this has only two dimensions that you can see here. You can see here only the, you can only define the length here, you can only see the width here, only two dimensions here. So all these things, for example, this is a ball. Is this a circle? This room, this space in the room, this is a three-dimensional space. Anything which is present in the room, we can see all the three dimensions of that object. So for example, this book, I can see this is the height of the book, this is the width of the book, and this is the length of the book. So this has all three dimensions. But if I just, keep only this, I see only this side of the book, it has only two dimensions, length and width. Okay, so if I take the page of a book and stick it here, that will show me only the two dimensions. But in the space where I am sitting in this room that has three dimensions, I can see three dimensions here. So that is where we call this two-dimensional surface as a plane. So what I'm saying here is all the points on the plane which are at an equal distance. Equidistant means at an equal distance from a given point. This given point is called the center. So all these points, I can have any other point here, or which is, I can call it D. Now all these points on this plane which are at an equal distance from O is any given point, so that makes a circle. Okay, so here I first made the circle and then I showed you all these points, right? What we can also do is, this is my point, this is a given point, and now I will just take other points. This is my A, this is my B. I can't make exactly point. It is like, that is why it is making small circles. Okay, so all these are points. And what I'm saying is this distance, I'll call this point. I'll call this point O. Okay, and I'll call this point A, I'll call this point B, I'll call this point C, this is my D, this is my E. So all these points are there in this plane. This plane is the laptop, screen of the laptop. And now what I'm saying is, if OA is equal to OB, all these points, if they are at an equal distance from O, which means OA is equal to OB is equal to OC is equal to OD is equal to OE, then these points actually make a circle with the center O. Here it is, I'm not measuring it, it may not be equal. So here, anyways, let me just expand this one. Okay, so that is where circle is a set of all points on the plane which are at an equal distance from a given point, which is called a center of the circle. When we are talking about all these points, right, set of all points on the plane, these points, set of points is also called locus of points. Okay. So this point O is the center, the point from where we are saying all other points on the circle are equal. That is the center. And what is this distance? We are saying it is all equal distance from the circle. Now, all this equal distance OA is equal to OB is equal to OC is equal to OD. What are all these distances? What is the term used to define them? They are all called the radius of the circle. The plural term of this radius is radii. So they are all the radius of the circle or the radii of the circle. Okay, clear until now? Any doubts? Okay, now we'll move further. Now, suppose we have a point A, okay, which is the center of my circle. Okay, I'll make a circle with this point as the center. Now, any point, for example, I'll have a point here B. This is the point B. Yes, this is the point B. Okay. Now, this AB, what is it called? I just now told, right? What is this called? This is called radius. Okay, this is the radius. Similarly, this is another point. I'll call it C. What is AC? This is also the radius. Now, what I'll do is, I'll join these 2 points which are there on the circle. I joined B to C. Now, these 2 points, I'm not, they are not the circle, center of the circle. B is not the center of the circle. C is not the center of the circle. B is a point on the circle. C is a point on the circle. And when I am joining 2 points on the circle, what is it making? This is making a chord. We call any 2 points on the circle when they are joined, this line which they make, that is called a chord. For example, if I have a point here and I call it D. Now I join C and D. What is C and D? CD then? CD is a chord. Okay, so CD will be a chord. Now, for example, I have a circle here. Okay, this is the center of the circle. I call it A. Okay, now I make a chord. This is one point on the circle. This is another point on the circle. Yeah. So this is point B and this is point C. Okay. Now I join these 2 points on the circle. What does it make? This makes the chord BC, as I have told. Now this AB is A is the center of the circle. AB will be the radius. Similarly, AC will be the radius of the circle, right? So I have 2 points which is on the circle which are joined to form the chord of the circle. Now, when these points they make, an angle with the center. They make an angle with the center of the circle. Then what will be this angle called? What will be this angle called? This is the angle. This is called the angle subtended by the chord. So here angle BAC. Angle BAC is equal to the angle subtended by the chord. Subtended means, subtended is the uh, term which is used to define the angle. It is, in simple words, it is just the angle made by these 2 points with the center. Okay, so this is the angle. This is the angle BAC. This is the angle subtended by the chord at the center. Now, what if I make, this is my line point on the circle D, and this is my point on the circle, I call it E. Okay, so this will be D and this will be E. Okay, now I join this D and E, and when I join this, these points are falling in such a way that when I join D and E, it passes through the center A. Okay, so DE is a chord. Why it is a chord? Because it is the line joining any 2 points on the circle. It is joining the 2 points D and E. So DE is a chord. But DE is also passing through the center of the circle, which is, center is the A. So AD equal to AE equal to the radius, right? So this special case of chord, this is a special case of chord which passes through the center of the circle. This is called the diameter. This is called the diameter of the circle. So diameter of the circle is the chord which passes through the center of the circle. And this is the what about, the length? What can we say about the length of the chord? This is the longest chord of the circle. Okay, so diameter will always be the longest chord. If you can try, making different chords on the circle, and you'll see for yourself that all the other chords will be smaller than the diameter, will be smaller in length. Okay, now I'll give another example of another property of the circle. So this is a circle I have formed. This is a cutout of the circle. Now, what I've done was I took this tape, this cello tape, I had just put it on the paper, drew the boundary, the outline, and then I have cut it out. Now this way when I have cut it out, I don't know what is the center of the circle or what is the diameter of the circle. So what do I do in this case? Okay, before I show you that, another thing now, you see, this is my circle. I rotate it a little bit. It looks the same. I rotate it a little bit. It looks the same. Now I rotate it again. You can't even make out how much I have rotated, and because it looks all the same, right? So when I'm rotating it, what I'm doing, you have learned about angles, right? I'm rotating it means I'm moving it by an angle. But even if I'm making it moving it by an angle, it looks the same. So what is this property called? This is called rotational symmetry, which means a circle, even if it is moving by any angle, it always looks the same. It is symmetrical. So the circles are perfectly symmetrical. They have a rotational symmetry. Now, if I want to, I was telling you, right, that how do I find out the diameter of this circle? What I need to do is, I'll just fold it into half. How do I fold it? I need to make sure that the edges are all aligned. Okay, and I fold it such that my edges are perfectly aligned. Okay, I folded it like this. This line, if you're able to see a little bit, not sure from this side it is visible or not. I think when it's a little bit folded, you're able to see the line, right? Now this line will be the diameter of the circle. When it is folded into, when it is like exactly aligned, edge to edge aligned, and the line that is formed is the diameter of the circle. And if I need to find out this, the center of the circle, then what do? I fold it first on this side, right? I fold it on this side. I'll fold on the horizontally other side now. Okay, again same, edges aligned. So what do I see? You see here, okay, it may not be perfectly visible, little bit is visible, right? So this is the intersection of these two lines that is making the center. Okay, so why is this makes when I'm putting it edge to edge, this is making the diameter, because if you see, diameter always cuts the circle into perfect half. The other side also, it is perfect half. And the two diameters, when they are in where they'll be intersecting, two diameters where they'll be intersecting at the center of the circle. Why? Because from this center of the circle, all the four radii will always be equal. They will be, the diameter is two radius which are in the same line that form the diameter. So that is where these two diameters, where they are intersecting, it forms the center of the circle. Now we'll come to the next concept. Next concept is, I'll give you 2 points. One is point A, another point is point B. Okay, this is my point A, this is my point B. Now, if I ask you, how many circles can you make through these 2 points? How many circles? First is how will you draw? If you are given these 2 points, how will you draw a circle? So we'll utilize the properties that we have learned until now. What is the property that we have learned? We have learned that center is at equal distance from any point which is on the circle. Now I am saying You have to make a circle which passes through A, which passes through B. So this means my center should be, I should find a point which is at an equal distance from A, equal distance from B. Okay. How can I do that? One simple way is I join A to B. Okay. I joined A to B. Now this is the center of my this line A to B. Okay, this is the center of the line. I call this center O. Now, because this is the center of this line, this will mean OA equal to OB. So this means if I use this O as a center for my circle, I can make a circle which will pass through OB. Okay. OA is equal to OB. But similarly, what I can also do is I take a point here so that this is my, I'll call it O dash. O dash. Okay. So now what I have done here is this OA. I found this point O dash such that OA is equal to OB. Right? And what I can do is I can use that as a center and make another circle which is passing through A and B. Right? I can do that, right? Similarly, I can make another circle here. I'll find a point here. Let me call it O double dash. Right? Now, here also, what I have found this point is that such a point where OA is equal to OB. Now, if I use O as the center, OB as the radius, right, I can make another circle here. Right? So, we can make multiple circles if we are able to find points which are at a equal distance from A and B, which are equidistant from A and B. So it all depends on how many such points we find. Okay. Now, how many such points we find is, we have, suppose, I'll make a new diagram here. So this is my point C, and this is my point D here. What I'll do is I'll join this point C and D just like I had done for A and B, right? When I found this point O, I joined AB and I found the middle point, and I could very easily use that as center of my circle and make the first circle. So similarly, I made this point. I used these 2 points were given to me, C and D. I joined it. I found the middle point. Now, what I'll do is from this middle point, this is the middle point. And what I'll need to do is I'll draw a perpendicular bisector. What is a perpendicular bisector? Perpendicular bisector. Perpendicular is something which is at an angle of 90 degrees. When I'm saying this line, suppose I call this line as AB. So when I'm saying this line AB is perpendicular to the line CD, this will mean that the line AB is at an angle of 90 degree to the is at an angle of 90 degree to this CD. Okay. What does bisector means? Bisector means when any line which is dividing the other line into two equal halves. Bi means two, sector means two parts. Sector means a section, a part. So bisector means something which is dividing it into two equal halves. So when I am saying AB is a perpendicular bisector, it means it has both the properties. It is at an angle of 90 degrees to that line, and it is dividing the line into two equal halves. So we had 2 points C and D. We joined these 2 points CD to make a line segment CD. We drew a perpendicular bisector AB. This perpendicular bisector is at 90 degree and is dividing CD into two equal halves. Now, any point on this perpendicular bisector will be at an equal distance from C and D. First example, this point O. This anyway we have told, right? It is dividing this into two halves, right? Another example, for example, I take this point. Okay, I call this point O dash. O dash. Okay. Now this O dash will be at an equal distance from C and D. OC will be equal to OD. How do I say that OC will be equal to OD? If you use the congruency property of the triangle, right? You see here, O dash is the common side for both the two triangles. What two triangles? First I'll write here. What two triangles are we looking at? O dash C O. Okay, and the other triangle is O dash D O. Okay. Now here, if you see O dash is a common side. So O dash is equal to O dash, we can see. Now we know that the angle O dash O C is equal to O dash O D, which is equal to 90 degrees, right? And the third is we know OC is equal to OD because we say that this is a perpendicular, AB is a perpendicular bisector, right? So do you see here side, angle, side? So this is the congruency property. These two triangles are congruent. These two are congruent. So then what does it mean? This means that our O dash C will be equal to O dash D. And for any point, this is, I made O dash here. I can make here O double dash, O triple dash, anything, any point you take on this line. Same congruency property will apply at every point, and then that is how you'll see that OC will be equal to OD. So you can use O dash as a center, make a circle, O double dash as a center, make a circle passing through C and D. You can take on this side, below 1 OB, take any point on OB, again, that will be at the same distance from C and D. You can use it as a center and make a circle passing through CD, right? So any point on the perpendicular bisector of a line joining two points will be equidistant from the 2 points and can be used as a center to make a circle passing through the 2 points. It may seem very confusing, but this is what I have explained. When I'm writing it, it may seem confusing. But what I'm basically saying is any point on the perpendicular bisector of a line joining 2 points, line joining 2 points is CD. Any point on the perpendicular bisector is O dash, O double dash. Okay, it will be equidistant from the 2 points. So here O dash C, O dash D, so they are equidistant. Any point which I'm putting on this perpendicular bisector, it will be at an equal distance from C and D. And this point O dash, O double dash can be used as the center to make a circle which is passing through the 2 points. Okay, so that is one of the properties that we saw. Now here until now we have taken 2 points. What about if I say let's take 3 points? Okay, so you have a point here A, you have a point here B, and you have a point here C. Okay, this is B and this is C. Okay, so now, okay, before we do this, okay, let's erase this. I don't want to make these 3 points. I will make another 3 points here. Okay, so I'll make another 3 points here. This, this. Okay, this is my A, this is my B, this is my C. Now these 3 points are collinear points. What are collinear points? Do you remember? You would have learned about it earlier in your lower grades. So these collinear points means all the points which are lying on a straight line. Or you can also say that these 3 points, when these 3 points are joined, they make a straight line. Okay, so these are collinear points. Now, how many circles can you make out of these 3 points? Basically, what I'm saying is you need to make a circle in such a way that all these 3 points A, B, C are lying on the circumference of the circle, or are lying on the circle basically. Can you make? How many you can make? Answer is 0. Why? Why you can't make? Because you cannot find a point which is equidistant from all these 3 points. You can't find a point which is at an equal distance from all these 3 points. For example, I say here, you know, uh, I say, okay, I'll take a point here. Now, it can happen that this can be equal from, it is same distance from A, it is same distance from B, but when you try to measure it, this may not be the same distance. Okay, so that is where we cannot have a point which is at an equal distance from all the 3 points. It cannot be equidistant from all these 3 points. So that is the reason you cannot make a circle which has all these 3 points lying on it. Okay? And if, another way, if you see it, uh, all these three are lying on a straight line, right? And when we are saying, you have, when we draw a circle, right? Circle is all curved at all the points, right? So that is something which is like, there's, I'm not talking about any proof and all, but simply also if you see, there won't be any 3 points which can be on the same line, which can form on the same line, because the shape itself of the circle is curved. When you learn about tangents later on, so that will be a line which is touching a circle. So it will touch only at one point. Okay, so it is, what I'm trying to say is we cannot have 3 points on a circle falling on the same line. That is why you cannot make a circle with the collinear points. But what about if they are non-collinear? For example, I have my A here, I have my B here, and I have my C here. So this is my A, this is my B, and this is my C. What are these points? These are non-collinear points. So non-collinear points are which are not on same line, or in another words, you cannot make a straight line by joining these 3 points. All 3 points. What, when you are joining all these 3 points, they won't make a single line, single straight line. So how many circles can you make by joining all these 3 points, which falls, not joining all these three, basically, which make a circle such that all these 3 points are lying on the circle. So let's try something which we have learned earlier. What we had learned here, I have the C and D 2 points. I make a perpendicular bisector, and any point on the perpendicular bisector will always be equidistant from C and D. I can use that point as a center and make my circle, right? So let's try that. What I'll do is I'll join A and C first. Okay, now I'll make a perpendicular bisector. Okay, this should be straight. Okay, now I'll make another line which is a perpendicular bisector of this AC. Okay, now as per what I told you, any point on this line will be equidistant from A, it will be equidistant from B, from C. Okay, now similarly, what I'll do is I'll draw the line AB, and what I'll do is I'll draw a perpendicular bisector to this line. Okay. Third, I'll join BC, what I'll do is, now I'll make a perpendicular bisector through BC. Okay, so I drew 3 perpendicular bisectors, one perpendicular bisector through AC, one perpendicular bisector through AB, third perpendicular bisector through BC. Now, at the point where all these 3 perpendicular bisectors are meeting, what is that point here? This is the point here, right? All 3 perpendicular bisectors are meeting here. Now, this point is falling on the perpendicular bisector of AC, which means I call this point, for example, I'll call this O. Okay. Now, this O is falling on the perpendicular bisector of AC, which means that any line drawn from O to A will be equal to O to C. OA will be equal to OC. I can use it as a center to draw a circle which has A and C as the radius. OA and OC as the radius. Now, similarly, this O is falling on perpendicular bisector of AB, which means OA is equal to OB, right? I can use it as a center to draw a circle which will pass through A and B, and the radius will be OA or OB. Similarly, this is falling on the perpendicular bisector of BC, which means I can use it as a center to draw a circle through B and C. So what this means is, using this O, I can make a circle which has the radius OA or OC. I can make a circle where the radius is equal to B. I can make a circle where radius is equal to OB or OC. So this means OA is equal to OB is equal to OC, right? I have found a point which is equidistant from all these 3, which means I can use that as a center, and these will be my radius. I can draw a circle, right? So I'll draw a circle. You can draw it through using your compass. I am drawing it on the canvas. So this is the circle. I am able to draw a circle passing through A, B, C. Now, if you see, when I joined A to C, C to B, B to A, it is forming a triangle ABC, right? Now, I have found a point O, which is equidistant from A, B, and C. And I'm able to draw a circle which I already wrote, that circle passing through A, B, and C using that O point as a center. So this circle passing through A, B, C, this is called the circumcircle. Circumcircle is a circle which is passing through all the 3 vertices of a triangle. O, which is the center of the circumcircle, which is at an equal distance from A, B, and C, that is called the circumcenter of the circle. Okay, so this is the circumcenter. O is the circumcenter, and the circle which is passing through A, B, and C, that is called the circumcircle. And how many such circles can we draw? We can draw only one circle, and that is what gives us the first theorem on circles, that there is only a one unique circle passing through three collinear points. There can be only a unique circle passing through three non-collinear points. Now, when you see closely, okay, this triangle which is formed, this is a acute angled triangle. Okay, so you can try doing this. Okay, what you can try doing is you can take three non-collinear points. Okay, A, B, and C. A. What you need to do is CB and C. So what I have done here is I have intentionally taken 3 points which when joined will form a obtuse triangle. This is a C. When I'm joining this, you can very well see that this angle BAC is greater than 90 degree, which means it is a obtuse angle, and this is a obtuse angled triangle. So what you need to do as a homework is you need to take three non-collinear points in such a way that they form a obtuse triangle. Draw perpendicular bisectors. Draw it for AC, AB, and BC. See where they join, and from the point which is at the intersection of these three perpendicular bisectors, that is the circumcenter. From that circumcenter and radius, as for example you are calling it O, from the circumcenter and radius as OA or OB or OC, which will all be the same, draw a circle. And similarly, you need to draw a right angle triangle. You know how to draw a right angle triangle? Basically, you need to take three non-collinear points in such a way that when you join them, it forms a right angled triangle. Similarly, for this, you need to draw the three perpendicular bisectors. Where the three perpendicular bisectors are intersecting, take that as a center and draw a circumcircle. And the homework is that when you do this, you need to come and tell me what is special about the circumcenter in case of a obtuse angle triangle, and what is special about the circumcenter of a right angled triangle. Okay, so that is your homework. You need to draw and see where it falls. Similarly, you need to draw for right angle triangle and see where that circumcenter falls. And then you need to come back and tell me what is it that you observed about the circumcenter. And from there, we will discuss the first exercise of the chapter, which is the exercise 5.1. Okay, any doubts so far? If not, we'll close the class today and we'll meet tomorrow. And I need to know the answer for the question that I have given, and we'll discuss the exercise 5.1. Bye bye.